We're now going to look at recessive linked diseases. And in this case, it's cystic fibrosis. So the question here says, a heterozygous male and a heterozygous female for cystic fibrosis allele have a baby. Complete the Punnett square to show the inheritance of cystic fibrosis from the parents above. So we know that they're heterozygous. And we know that the common letter used for cystic fibrosis is F, but the exam can give you any letters for any disease, to be quite honest. So we know that big F means no disease because there's no recessive allele. Little f means they have the disease. This means they have the disease because they've got two recessive alleles. So big F, little f means they are a carrier. They don't have the disease, but they're carrying the small f recessive allele. So the heterozygous male, heterozygous means that they've got two different alleles. So it can't be big F, and it can't be little f, little f. So it's got to be big F, little f. Big F, little f. We know that both parents are heterozygous. So you need the genetic cross diagram, big F, big F, big F, little f, big F, little f, little f, little f. So now you can answer this exam question. Explain how two parents without cystic fibrosis can have a child with cystic fibrosis. So the only way for a child who has two parents without cystic fibrosis to get cystic fibrosis is if both parents are carriers of the cystic fibrosis allele. So how do you answer this exam question? In the exact same way as I showed you with the eye color one. You firstly highlight the genotype of each parent. You then circle the genotype of the child that we're looking at, and then you draw an arrow from the alleles they inherit, and then what is the percentage chance. So the genotype of each parent, so each parent's genotype is big F, little f. They carry the recessive small f allele. So each parent passes on the recessive allele. Each parent passes on the small f recessive allele. The child has two small f recessive alleles. And the chance of this happening is, look here, oh, they need two small f's, two recessive alleles. So it can't be that one. So if this child is born, then that's going to be a carrier. It won't have cystic fibrosis, no cystic fibrosis, 25% or a 1 in 4 chance. So the chance is 25%. That there is how you'd answer a question on the inheritance of cystic fibrosis from two parents who do not have cystic fibrosis. So you can pause the live stream here to attempt these questions, and the answer will follow. And if you don't want to answer them now, I'm going to continue on with sex inheritance in a moment. Pause the live stream to attempt these questions. The answers will follow. Pause here to go through your answers. The next topic's going to follow now.